We're still in chapter 4, diverse architectural styles. We finished with service-oriented architecture. Now we will start microservice. The second part of chapter 4, microservice architecture. Let's start with taking a look at the historical development of architecture styles. At the beginning, there was no decomposition. All components, like user interface, like business logic, like database, were all stuck together in one big piece of code, which is called monolithic architecture. Then people started organizing the code into separate parts that we call layers. So we have presentation layer, we have the logic layer, and we have the data layer. And this is called layered architecture, like the one seen in chapter 3. After that, this, let's say, big layer were split into separate services. This is a service that contains a user interface and a service. The second part also contains one specific calculation, one service with its user interface. So the application is split horizontally into many sub-layers, and all these layers share the same database. This is what we call service-oriented architecture. Finally, we have more decomposition, where each small block works on its own. The database now is split into small separate databases. In this way, each part of the application contains its own user interface, its own logic, and its own database. It is totally independent from other microservices. Each one of them is called microservice, and the architecture is called microservice architecture. In this way, each microservice, each small block works on its own, so changes in one block don't mess up and don't affect the other microservices. We can say that microservice is the natural result of the architecture style progression through the time. In line with the human tendency to this specialization all over the history, also microservice is the pinnacle of what the architecture art has reached. Still, for now, is the peak of what the architecture art has reached. The biggest microservice is the biggest change in the architecture since 2012. Like what service-oriented architecture did in 2006. So Mainly, we are moving from monolithic to multi-layered to microservice to more specialization. The advantage of microservice architecture: different teams can work separately and independently on different microservices. This is a team work on a microservice and provide a service that is totally independent from all the other services. Teams can build new functions and develop the business capabilities without impacting any other microservice. Teams could use different programming language, and this is the main advantage of microservice is that each microservice can adapt its own technology stack. This microservice for the profile management is using Python. This microservice for payment processing is developed using Go. This microservice product catalog is implemented using Java on the Azure cloud, Go on the Google cloud, Python on the Amazon cloud. So they don't need to share anything or to use anything in common. This is the main advantage of the microservice architecture style. Let's go deeper into the topology of microservice. In fact, the microservice architecture style is made up of a single purpose separately deployed services. Single purpose that does only one specific thing. Separately deployed service that are accessed through an API gateway, typically REST. A microservice, so, is a unit of software that does only one thing, but it does it really, really well. Each service in turn accesses its own data or makes requests to other service to access data that the service doesn't own. This is a service, its own database. This is another service with its own database. If this service needs this database, it has to access to the service, ask for the database, then the service will give the database the data, needed data. All these things are happening behind the scene. Indeed, the API gateway, the role of the API gateway is to hide the location of the service and the location of the database. So when we ask for a service, we ask the API, and we don't care about the complexity behind the scene. For the granularity level of the decomposition, it is not about the size of the service. We don't decompose according to the size, but rather what the service does. It must do only one thing. Example, we suppose like a service sending thousands of emails to customers. Because it does only one thing, this would in fact be considered as microservice, despite the fact that it does a lot of calculation, but it is only one thing. Bounded context is an important aspect in the microservice philosophy, since each service typically owns its own data. This is a service and this is its own data. All of the source code representing some domain or subdomain, along with the corresponding data structure and data also, are all encapsulated in one unit. This is the bounded context. Bounded context is the core philosophy of the microservice. Without bounded context, it will be a mess. Let's suppose that we have, for example, let's say 100 microservice, and each microservice has its own database. Suppose that we don't have the bounded context. If we want to access to any database, the system will allow us to access to any database we want. And this is a really big problem, because if we want to modify something in this database here, something in the structure, I mean, for example, adding one more column, we need to change the code here and here and here, the code that access to that database, and this will be a mess. With a bounded context where this database is owned by only this service, if there is something to change in this database, or to change the technology of this database, for example, the modification will be only here, and the only service that will be affected is the service that is inside the bounded context, and all the other services will access to that service to get the data. But it is sometimes necessary to share data between two or more services. When data is shared between services, the bounded context is extended to include all the shared tables as well as the service that access the data. Sometimes we need to break the rule. For example, we need this service to access to this database and also to this database. We can allow this as an exception, but we will change the bounded context like this. And this will be the new bounded context. Of course, it is not recommended to do this so much and with so many databases, 2 maximum, let's say 3 or 4 maximum, but it is always good to stay with the microservice rule, bounded context like this. How to make sure that no one of the development team accidentally created coupling points, dependent points between each other. There is a method that architects usually do, is enforced heterogeneity, means mandating, forcing that each development team use a different technology stack. If we force this team, for example, to use Java, and this team to use Python, so we will be sure that the microservice will be independent. And this is what we want in microservice architecture. We can ensure that by giving different technology stack for each microservice. Microservice favors decoupling. Favors decoupling means prefer independent microservices. In fact, the original version of microservice included the user interface as part of the bounded context. However, what does it mean part of the bounded context? Means that the user interface also is a part of the bounded context. Yani user interface is here. This is the user interface, and the bounded context will be like this. So another user interface for another service in the bounded context of that microservice. This is a solution. In this case, we talk about micro front-end user interface, where this is a bounded context including user interface, business logic, and database. This is another user interface, another bounded context containing the user interface, the service, the API, the service, and the database. However, some particularities make that goal difficult. Thus, we need sometimes to share the same user interface for many microservices, but still the bounded context in the database and the service still working, but not for the user interface. So, when to consider this microservice style? When it is feasible to break apart your application functionality into dozens or even hundreds of separate and distinct pieces of functionalities that are independent from each other. Of course, sometimes our application cannot be split into multiple independent microservices, so we don't use this style. Also, when your application requires high levels of agility, agility and microservice is a good combination to create applications, because it is easy to locate code and make coding changes. Testing also is easy because the testing scope is usually reduced to a single purpose service, so we can find anything we want in that bounded context. So microservice and agility are in love. Also, when you have high fault tolerance and high scalability needs, it's clear that microservice has a high fault tolerance, because if one microservice become not functional, nothing will happen to the system, only to that microservice. When to avoid this style? If your data is tightly coupled and monolithic in nature, sometimes you have application that has tightly coupled data. Really related data cannot be independent. In this way, it's better to avoid the microservice architecture. Also, if you have tight cost and time constraint, because the microservice is costly. And also, creating a microservice may be time consuming. So if you don't have a lot of money, if you don't have time, don't use microservice.